Yeah, very good morning, dear. Today we'll discuss about the problems from the electricity chapter and based on the formula series connection and then as well as parallel connection. May I know the formula for finding the resistors, equivalent resistors in series when three resistors are connected in series?
So R equivalent is equal to R1 plus R2 plus R3.
Yeah, R equivalent resistance is equal to R1 plus R2 plus R3 when they are connected in series. Is it
Yes.
right? And what about when they are connected in parallel?
1 by Req is equal to 1 by R1 plus 1 by R2 plus 1 by R3.
Yeah, very good, Amma. 1 by R equivalent. That is RP stands for R parallel. Don't get confused. Is it right? And RS stands for series.
R series.
Okay. So keep it in mind. So these are the two formulas. Based on these two formulas, we'll discuss the few problems today. Now look at here. The problem, first problem. A battery of 9 volts is connected in series. So clearly given what type of connection is given here. Battery is connected to in series with a resistors of 0.2 ohms, 0.3 ohms, 0.4 ohms, and 0.5 ohms and 12 ohms respectively. How much current would flow through the 12 ohms resistor? So what type of connection is given in the question?
Series connection.
Yes,
So what is
series.
our first step basically?
We should write it for given data.
Given data. Very good. Total resistance is R. Is it right?
Yes, sir.
So total resistance is equal to 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. Is it right? So this is what we call equivalent resistance. That equal to how much? 13.4 13.4 ohms. Then current flowing. What is according to Ohm's law? Formula is
V is equals to I.
V is equal to
IR.
IR. Very good. So what is the value of V here?
9.
9 volts. Very good. So battery value is given. So according to Ohm's law, V is equal to IR. So to find current, you know the value of R, you know the value of V. Substitute in that. Is it right? So I is equal to V by R. V is 9, R is 13.4. So what is the total value here? 0.67. What are the units of current?
Ohm.
Units
Ohms.
of current.
Amperes.
Ampere. So 0.67 amps. Don't forget to mention the units, whatever it may be, either current or volts or any resistor also. What are the units of resistance?
Ohms.
Ohms. Is it right? Volts, V.
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 Current,
I.
A. Units, no, units.
Units.
Here, yeah, amperes, volts, and resistor, ohms.
Ohms.
Right? So remember these points, very, very important. And the current through 12 ohms resistor is 0.67 amps. Sir, how sir means whenever they are connected in series, look at here, let me explain you on the screen. So when they are connected in series, no matter which how many ohms resistor is there, simply here is a battery. Here is a resistor 0.2, 0.3, 0.4, 0.5 and 12. Is it right? All are connected in series. So here it is plus minus 9 volts battery. Now the amount of current which is going from here I is same amount of current will flow through all resistors. Is it right?
Yes.
It
Yes,
means
sir.
no matter which resistor and how much current is flowing, but the current flows through all resistors is equal. Why? Because they are connected in what? Series. So keep it in mind. This point is enough. Whenever the number of resistors are connected in series, the current flowing through all resistors is
Same.
same. Keep it in mind. Now, judge the equivalent resistance when the following connections connected in parallel. Simply, I think I have already told you almost same in both cases. 1 ohm and 10 power 6 ohms are connected in
Sir,
parallel. Yeah, please.
can you show once first problem, sir?
Yeah, you can watch later, Nana, again. Okay, after the end of the class.
Okay, sir.
Please. It is already broadcasting now. You can see here 1 ohm resistor and 10 power 6 ohms. 10 power 6 means how many zeros? 10 0, 6 zeros. Is it right?
Yes, sir.
So 10 lakhs ohms resistor. Simply 10 lakhs ohms resistor and 1 ohm resistor are connected in parallel. When they are connected in parallel, what is the equivalent resistance formula?
By Req is equal to 1 by R1 plus 1 by R2.
1 by R parallel is equal to 1 by R1. That is 1 by 1. Is it right?
Yes, sir.
Plus 1 by R2. That is 10 power 6.
6.
Is equal to cross multiply 10 power 6 plus 1 by 10 power 6. So how much you are getting? 10 power 6 plus 1 is again almost 10 power 6 only. There is no much difference. So 10 power 6 by 10 power 6 plus 1. So same answer. Here it is in 1 by R form. Here it is in a reverse form, equivalent resistance form. So same amount of value you will get. Approximately 10 power 6 by 10 power 6. So almost how much? When they are connected in parallel, the amount of resistor is 1 ohm. Now second situation, 1 ohm and 10 power 3 and 10 power 6. Now 3 resistors. Is it right? So for first situation, equivalent resistance is approximately 1 but less than 1. Okay, here less than 1. Why? Because denominator value is more than numerator value. Now situation 2. 1 ohm, 10 power 3 ohm, 10 power 6 ohms are in parallel. So here 1 by R equivalent is equal to 1 by 1 plus 1 by 10 power 3 plus 1 by 10 power 6 ohms. Is it right? So what is the LCM of these three? 1, 10 power 3, 10 power 6 LCM is? Respond quickly. Anyone? Respond quickly.
Sir, can you repeat the question?
What is the LCM of 1, 10 power 3, 10 power 6?
10 power 6.
Yeah, 10 power 6 is the LCM. So how much you will get here at the numerator? 10 power 6. Here more 10 power 3. Here 1. Is it right? So 1
Yes.
by R is equal to LCM here it is 10 power 6 you will get. Why? Because it only 1 is there. 10 power 3 there still more 3 10 power 3 you will get. Here 1 you will get. So this is 1 by R equivalent. Then find R equivalent from this. Okay. R equivalent is 10 power 6 is nothing but 10 lakhs by these all something what how much you got 10 double 1 double 0 1 double 0 1 value. So here also approximately less than 1. So how much it is? 0.099999 and so on. So these are the two resistors when they are connected in parallel. Equivalent resistance is 0.9999. Here it is also less than 1 but approximately 1 here. Okay. So this type of questions there is a chance to get into the board exam. Yeah, can you read this question? Anyone?
Yes, sir.
Yeah, please. Yeah, please, Nana.
An electric lamp.
Yeah. Your voice is not audible. Yeah, you read loudly, ma.
Yes, sir. An electric lamp of 100 ohms, a toaster of resistance 50 ohms, and a water filter of resistance 500 ohms are connected in parallel to a 220-volt source. What is the resistance of an electric iron connected to the same source that takes as much current as all three appliances? And what is the current through it?
Okay. See, simple question here. An electric lamp is there of how many ohms? 100 ohms. And toaster is also there. Toaster is also there. How many ohms?
50 ohms.
50 ohms. And a water filter of resistance is how many ohms?
500 ohms.
500. All are connected in parallel. Is it right?
Yes.
Then what we have to do here, we have to find the equivalent resistance of these three.
Yes, sir.
The equivalent resistance of these three is also equal to the, what is the resistance he asked that electric iron connected to
Yes.
the same source. So that takes this much as much as current all of, see the amount of current flowing these three is also equal to the amount of current flowing through the same electric iron. Is it right? So equivalent resistance, yeah, please.
Sir, but here they are given for electric iron 220 volts, no, sir.
No,
Not
this
ohm.
is battery, means our source it is.
Uh-huh.
220 volts is source, okay?
Yes, sir.
Source is same for this electric iron. Here one setup is there with same source electric iron, okay? Here one setup, that is here our source, and here three are connected parallelly. What are those three?
Electric lamp,
Electric lamp,
and water filter.
water filter.
Yeah, electric lamp, toaster, and water filter. And here clearly mentioned, connected the same source takes the as much as current as all of three appliances. The amount of current taken by these three appliances should be equal to the amount of current which is taken by iron, electric iron. It means what? Same voltage, same current. What about resistance then? Also same.
Same.
So here three are there. You have to find the equivalent resistance. That equivalent resistance is also equal to its resistance. Is it right? But not sum of these three here. 100 plus 500 plus 50 is not correct answer. That is wrong answer. Why? Because they are connected in which combination?
Parallel
Parallel.
combination.
Yeah, parallel combination. So try to understand this question. This type of questions may will make you to confuse here. So try to understand here. First write the given data. Resistance of lamp is 100 ohms. Resistance of toaster is 50 ohms. Resistance of filter is 500 ohms. And the power supply is 220 volts here. Okay, battery. And here to find resistance of iron, current through iron. Okay, we are talking about electric iron here. So formula is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So, and V is equal to IR. V is equal to IR is according to which law?
To
Ohm's
find
law.
Ohm's law. Yeah, very good. Now solution. Let's R be the equivalent resistance of these three. Then find R 1 by R is equal to, this is the formula. Substitute here 1 by 100 plus 1 by 50 plus 1 by 500. Is it right? LCM of these three is
500.
500. Is it right? Very good. Now LCM is 500. How many times of 100 is 500? 5 times. 50 is 10 times. 500 is 1 time. So this is 15, 16. So 16 by 500. That is 1 by R. Then R is equal to 500 by 16. So how much you are getting here? 500 by 16 is nothing but. You can convert into decimals also here. Okay. According to Ohm's law, V is equal to IR. Substitute the value of R and V both. So I is equal to V by R. V is 220. R is 500 by 16. So 16 goes in the numerator. Okay. Then 0, 0 we can cancel. Then final answer you are getting is 7.04 amps current. Is it clear? The amount of current which is flowing through these three appliances is also same as the amount of current flowing through which
Iron.
device? Electric iron. And what about the voltage of electric iron?
220 V.
So simply find R. R is equal to V by I. What is the V value of electric iron?
20.
220. By I is same.
7.04.
7.04. How much you will get? Do it fast and tell me the answer. All of you. So the current flowing drawn through these three appliances is this. And the next step is find the equivalent resistance here. 31.25 ohms. Is it right? 31.25 ohms.
1.25, sir.
Yes, sir.
Yeah. Is also equal to 500 by 16. Ma. You can recheck.
Yes, sir. 500 by.
Why? Because their equivalent resistance is also equal to the resistance of the electric iron. Okay. As per the given statement. Let me move to the next question. How can three resistors of resistance 2 ohms, 3 ohms and 6 ohms can be connected to give a total resistance of 4 ohms? Okay. So please connect these three resistors so that gives 4 ohms as the equivalent resistance. What is the combination of these three resistors? Is it 3 out of 3 or in series? No, it's not possible. If you connect 3 out of 3 in series, 2 plus 3 plus 6, how much? 10.
10.
10 ohms. There is no option.
11
So
ohms.
11 ohms, sir.
11, very good. Thank you so much. 11 ohms. There is no option in this. Is it right? So we are not supposed to connect in series. Connect these two in parallel. 1 by 2 plus 1 by 3. How much is LCM? 6. And here it is 5. Is it right? Reverse is 5 by 6. 6 by 5. 1.2. So 1.2 plus 6. 7.2. So no combination. Connect 3 out of 3 in parallel. 3 out of 3 in parallel. Or first was in series and these two in parallel. Check any possible combination so that gives equivalent resistance is how much?
Sir, if we connect total 3 of them in parallel, we get 6 by 6. That means 1 ohm.
1 ohm. So second one is right. 1 by 2 plus 1 by 3 plus 1 by 6. LCM is 6. So here 2 3 times plus 3 2 times plus 6 1 time. So here numerator is 6, denominator is 6. Answer is 1. So for second situation, how we have to connect?
All 3 in parallel.
All 3 in parallel. So in what way we have to connect such that so that we can get the equivalent resistance is 4. Check it. Fast. Wait fast, all of you. Excuse me. Yeah. So you can see here the first given data values. To get R equivalent as 4, the circuit is as shown. R2 and R3 are in parallel. You can see here. If you connect like this, maybe you are getting this equivalent resistance as 4. Please check it once. Connect these two are in parallel. And this is in series. So 2 plus 1 by 6 plus 1 by 3. What is the LCM of these two? How much you are getting? LCM of these two is 6. 6 is LCM, means 1 plus 2, 3 by 2. So these two are a separate combination. This is a separate combination. So this is 3 by 2, reverse 3 by 6, reverse it. 6 by 3. Then this is 2. So 2 plus 2 is right. Is it right? Yeah, please turn off your cams. Don't turn on your cams here. 1 by R parallel is equal to R2 plus R3, that is 6. 1 by 6 plus 1 by 3, that you are getting is 3 by 2, that equal to 3 by 6, that equal to 1 by 2. And RP is equal to 2 ohms you got, and R1 is 2 ohms. Both are in series. So 2 plus 2 is 4. Nana, very, very important question. Nana, this one definitely will get, there is a chance to get in your board exam for 2 marks. Keep it in mind. Okay, 2 marks definitely you will get, Nana. Not only like this, how this type of situations, how can 3 resistors are connected? So that instead of 4 ohms and instead of 1 ohm, maybe they will give different values, but definitely will get one question based on this type of questions. Okay, for 2 marks. Yeah, one more question. Second bit in this, we already done that. 3 out of 3 has to connect in parallel, so that we'll get equivalent resistance as 1. Is it right? An electric lamp whose resistance is 20 ohms and a conductor of 4 ohms resistance are connected to a battery, and calculate the total equivalent resistance in the circuit, the current flowing through the circuit, and the potential difference across the electric conductor and lamp. Can you do it fast? Anyone respond quickly? No, you are not responding. It means you are not in the class. You are doing some other work. Is it right?
No, sir.
Yeah, then respond quickly, all of you. Do you want to read out your names? All of you respond quickly. Read the question and try to solve it. 3 questions are given here. First, what is our step to identify the given data? An electric lamp whose resistance is 20 ohms. So here it is electric lamp. What is the resistance of electric lamp?
20 ohms.
20 ohms. And a conductor of resistance is how much?
4 ohms.
Sir,
Yeah,
total resistance 24 ohms.
24 ohms. They are connected in series. Okay.
Hmm.
The total resistance of the circuit is
24 ohms.
24 ohms. Very good. And circuit voltage is also given 6 volts. Ammeter current, we have to find the current through the circuit is.
Current is 4, sir.
Current is 4, 24 by 6. Is it right?
6 by 24.
6 by 24. Then how you will get 4?
We won't get 6 by
1
24.
by 4.
1 by 4. It means how much? 0.25.
0.25.
25.
Yeah, very good. 0.25 is the correct answer. Then third bit. The potential difference across the electric conductor and lamp. Potential difference is nothing but voltage.
Voltage.
Across it and across it. That if you find the value of the voltage across it, use the value of current is same and resistance is 4. And here resistance is 20, current is same, like 0.25. Separately, we have to calculate. Okay. R series, you know that. R series is how much? 24 here, 4 plus 20. So here onwards are the questions. First question is 24 ohms. Total equivalent resistance of the circuit is, they are connected in series, 4 plus 20. So 24. Second bit is current through the circuit. V is equal to IR formula. Is it right? V is equal to IR. I is equal to V by R. V is given 6 by 24. That equal to 1 times 6 4 times. So 1 by 4, that is 0.25 amps. Third bit, potential difference across the electric conductor and lamp. Electric conductor. So V is equal to IR formula. Is it right? So potential difference across the electric lamp, if you first find, then V is equal to question mark. V is equal to what formula? I
I by R.
IR. I by R. Is it right?
First one is 4.9 and second one is 5.
First one is how much? 4.9.
0.9.
How much? 0.9.
4.9, sir.
4.9. Second one?
5.
5. Maybe wrong, dear.
5 and 1 it was.
0.49, I guess, sir. Yes.
Zero point. No. Actually, here a total voltage is how much is there? 6 only. If you add these all, then also you should get 6 only. Then here you are getting around 9.9. That is wrong. Recheck.
Yes.
Whatever the value you will get here, V1 value and here V2 value. Okay. It should be, sum of those two values should be equal to the total voltage. Is it right?
Sir, it is 1.
Yeah. So we'll check with lamp here. V is equal to IR formula. I is how much? I is common through both. Common for both. Why? Because they are connected in series. So 0.25 into R1 is how much? Electric
20.
lamp. Electric lamp 20. Is it right? Into 20. So 1 by 4 into 20 is how much? 5.
5.
So the resistance of the bulb is how much? No, voltage across the bulb is
5 volt. Sir,
5
it is
volt.
1 volt.
Then it is 1. Is it right? So now look at here. For the second one, potential difference across the electric conductor. Same formula. V2 is equal to I into R2. I is same. How much is I? I is 0.25. Is also equal to 1 by 4. Into R2 is how much? 4.
4.
So 1 by 4 into 4 is gets cancelled. Then the final answer is 1. 1 volt. Sum of these two is equal to how much?
6.
6. So that is the equivalent voltage here. You can see here some of the voltage. Someone turn on your video. Nana, please turn off your video. So here you can see the total resistance is 24 ohms. The total current is 0.25 amps, and potential difference across the lamp is 5 volts, and potential difference across the conductor is 1 volt. So these type of questions you will get for 5 marks. 5 marks, okay? 1, 2, 2, like that. Or they will add one more bit here to give for, or for 4 marks also. 1, 1, and this is 2. 4 marks. For case-based questions also, there is a chance to get this type of questions. Very easy, Nana. This question, can you read once? In the circuit diagram given, suppose the resistors R1, R2, and R3. So here 3 resistors are there: R1, R2, and R3. Have the values of 5 ohms, 10 ohms, and 30 ohms respectively, which have been connected to a battery of 12 volts. Here two batteries, how much? 12 volts. Calculate the current through the resistor, each resistor, and the total current and the total resistance. Is it easy? Do it fast. First question is what? Calculate the current through each resistor. For first resistor, how to calculate? V is equal to IR, then IR is equal to I is equal to V by R. What is the voltage here? How much is the voltage value? 12 by R is how much for first resistor? 5. 5 2 times 10, still 2 remainder, 0.4 amps. Is it right? Then second resistor, again I2. V is 12 by R is 10, that equal to 1.2 amps. Third resistor, I3. V is 12, R is 30. How much it is? 0 point something. 0.120 means 4. 0.4 amps. These are the 3 currents. First bit is over. Second bit, the total current. They are connected in parallel. How you will get the total current? Sum of these
All
three.
the 3 values.
Yeah, I1
Done.
plus I2 plus I3 is equal to I. So 2.4 plus 1.2 plus 0.4. How much it is? 2 plus 1, 3. 3 plus 1, 4. So 4 amps. Is it right?
Yes, sir.
Second bit over. What is the third bit? Total resistance. Total resistance is
Sir, 0.3.
equivalent resistance are
Yes, sir. Equivalent resistance. It is there.
1 by R equivalent is equal to 1 by 5 plus 1 by 10
Plus
plus
1
1 by 30. Is it right?
LCM is 30.
LCM is 30. Very good. 5 6 times,
6 plus 3 plus 1.
10 3 times, 31 times. So how much it is? 10.
10 by 3.
10 by
10 by
3.
1 by
30. Reverse it. This is 1 by R equivalent. Is it right? Then
Yes,
R
sir.
equivalent is equal to 30 by 10. So they are equal to 3 ohms. So this is third bit. C, this is second bit. B, and this is first bit. In that each current are there I1, I2, I3. So these are the 3 values. Okay, very easy. If you want to see the step by step, I will display here. Just observe those 3. Given data first R1, R2, R3.
Yes, sir.
And then V is equal to given. To find first question, effective resistance R parallel, that is a total resistance here C bit, total current I D bit, and that is I1, I2, I3 current in each 3 bits are there. So formula for parallel connection is 1 by R1 plus R2 plus R3, and V is equal to IR formula. Solutions for this one, 1 by 5 plus 1 by 10 plus 1 by 30. Is it right? So how many times of 5 is 30? 6 times. How many 5 times of 10 is 30? 3 times. Here it is
10.
1 time. Okay. So here 6, 3, 1 by 30 is equal to, here finally you got 3 ohms. That is right answer. Keep it
Yes,
aside.
sir.
And then I is equal to I1 is equal to V by R1. Simply you got this 2.4. And here it is 1.2. And the next one is 0.4. We got this. These 3 I values we got. And sum of these three is
4 amps.
4 amps. Very good. So with this question is over. Very simplest way. Answers. Effective resistance 3 ohms. Total current is 4 amps. Each current in each resistor is 2.4, 1.2, 0.4. Is it clear? Yeah, read this question and try to answer it. What he asked in the question? Total resistance and the total current flowing. Only 2 bits. Total resistance. To find total resistance, look at here how they are connected first of all to the battery. Clearly given in the diagram now.
So equivalent, sir.
See here. Not all parallel, not all in series. Parallel and series combination are there. Is it right?
Yes, sir. Yes,
These two
sir.
are in parallel. These 3 are in parallel. Now find the equivalent resistance here and here. And those 2 equivalent resistances are connected in parallel or series. Check it fast.
Series.
Series, no. First to find its equivalent resistance. First find its equivalent resistance next. Then their equivalent resistance just add. Those are connected in series. Do it fast. Don't delay it.
Sir,
Yeah,
the resistance for R1 and R2 is 8 ohms.
8 ohms. Huh? So 1 by 10 plus 1 by 40. Is it right? 40 is LCM. And here 4, here 1, 5. 5 by 40 and 40 by 5. That equal to 8. Very good. 8 ohms. For next one, 1 by 30 plus 1 by, this is 1 by RE.
Sir, 6 ohms.
6 ohms. Huh? Very good. Then
10
find the
ohms.
equivalent resistance then. Final resistance. 1 by 20 plus 1 by 60.
Sir, 14 ohms.
14 ohms. Very good. The next condition is, next question is total current flowing through the circuit. V is equal to IR formula.
Sir, for R1 and R2, R3, R4 and R5, we got values and then we have to add them now, sir.
Yeah. Here equivalent resistance is 8. Is it right? Here equivalent resistance, how much you got? Here it is LCM 60. 2 times, 3 times, 1 time. 6 by 30. 6 by 60. Then 60 by
10
6.
ohms.
10 ohms.
10 ohms, sir.
10 ohms. Is it right? Dear,
Yes.
please check your answer once. Is
Yes,
it 6
sir,
ohms
yes.
or 10 ohms?
So if we cancellation, no, sir.
Which one, Anna?
6 ones are 6 tens are.
Yeah, that's why I wrote 10 ohms.
Hmm.
No, that dear got some different value. That's why.
I got 10.
Yeah, very good. Yeah. Now look at here, equivalent resistance. Here we got 8 ohms. Is it right? Here we got 10 ohms.
Yes, sir.
Then they are connected in series or parallel now. These two, this equivalent, this 10 and this 8 and this 10.
Series, sir.
Series. So how much is the equivalent resistance?
18 ohms.
10 plus 8, 18 ohms. The question is over. The total resistance is how much? 18 ohms. Is it right? Then total current V is equal to IR. I is equal to
V
V
by
by R. V is how much?
12 volts.
12 by 18, sir.
12 by 18. 6 2 times, 6 3 times.
3, sir.
So 2 by 3, how much? 0.66
Amps, sir.
amps. Very good, dear. Thank you so much. Amps. Is it right? Excellent
Yes.
answer. So don't forget to mention the units, Nana. Very good observation here. So with this question is over. So if you want to write step by step, you note down. You can see here. So keep a diagram aside. However, they will give this diagram clearly mentioned as shown in the arrangement. Okay. given data. Total resistance to find, total current to find, are parallel here for first two, that equal to, and then we'll do for these two first. 1 by 10 plus 1 by 40, that equal to, you are getting 4 as the resistance here, equivalent resistance for this. 8, not 4. Okay, are parallel 1. So here first parallel 1 setup, then keep aside. Second one, again these three are connected in parallel. So 1 by parallel 2. Parallel 2 means second setup of parallel connection. Second set of parallel connections, 1 by R3 plus 1 by R4 plus 1 by R5. So 1 by 30 plus 1 by 20 plus 1 by 60. LCM is 60. So here 30 2 times and 20 3 times and 60 1 time. So here it is 6 by 60. If you reverse it, then R parallel 2 is 10. So equivalent resistance is equal to R parallel 1 connection plus R parallel 2 connection. That equal to 8 plus 10, that equal to 18 ohms. First bit is over. Now second bit, total current in the circuit. V is equal to IR, then I is equal to V by R.
R.
V is equal to given 12 volts. So
12
12 by
18.
18. So here 6 table, 6 2 times, 6 3 times. 2 by 3 is 0.66 amps.
6 amps.
Very good, dear Nana. Very good answer. 66 is also nothing but 0.67. Whenever you will get this type of values, remember after decimal 0.6666 and so on is there, means leave the first value and instead of this value you can write as 7. Okay, so this it is 0.67. Now can you say what is the value for this? 0.33333?
0.3 bar.
0.34.
4.31.
Yeah, 0.34 is the right answer. Why? Because we'll leave the first value and remaining 3 and all 3's together we'll write it as 4. So 0.34 enough. Or you can also write 0.3 bar, but we don't want to mention any bar symbol here. We want a fixed value here. Okay, amps like this. Okay, is this question is clear?
Yes, sir.
Yeah, one more question please. Check it once. Show how you would connect the 3 resistors. How many resistors given here? 3 resistors. Each of resistance is 6 ohms. So that the combination has the equivalent resistance of 9 ohms and 4 ohms. So here 3 resistors are there. The value of each resistor is how much?
6, sir.
6 ohms. R1 is equal to 6. R2 is equal to 6. R3 is equal to
6.
Now connect these 3 resistors such that you will get the equivalent resistance is 9 and you will get equivalent resistance is 4. 2 questions are there. I think we have discussed this type of question just before.
Second problem, sir.
Yeah, very good, dear. Yeah, please.
Add 3, we are getting 18, sir.
Yeah, if you connect in series, then you will get 18. So a series combination is wrong.
Yes, sir.
Do one thing. First connect one resistor in series, remaining 2 in parallel.
If we connect in parallel, we'll get 1 by 2, sir.
No, here 6, 6, is it right? Here also 6.
All three, if we connect in parallel, we'll get 2 ohms.
So, but there is no 2 here, is it right? 4, 9 is there. Is it right? Now check it once. This is in series and these two are in parallel.
We'll get 9, sir.
You are getting 9 now. 1, 6 is 6, they are parallel. So 6 by 2 you will get. That is 3. Final answer. 3 ohms. Is it right?
6 plus 3, 9.
6 plus 3 is 9. So first condition is satisfied with this setup. Is it right? Then what about the second one? Try to draw the diagram. If you connect 3 out of 3 in parallel, how much you are getting? Check fast. There is no other combination. 3 out of 3 in series.
So then we are getting 18, no, sir.
No, that combination is failed. And 3 out of 3 in parallel. How much you are getting?
2 ohms.
6 by 3 you will get, I think. Is it right?
Yes, sir.
Yes, sir.
2
We get
ohms
2
you are
ohms.
getting. Then how to connect? Is there another way of combination to connect them to get 4? Do it fast. Check it once. Any other way of combination? So here your subject will get tested. Nana. Definitely there is a chance. Why not? Check it fast. Don't delay, Nana. I think we are running out of time. I have to stop the class again. Any other ways? First one, let me display here. To get 9 ohms, we have to connect 2 in parallel and 1 is in series. Is it right? That is done.
Yes, sir.
This is 9 ohms we got. To get 9 ohms, R1, R2 are connected in parallel, R3 is connected in series with them. Then to get 4 ohms, R1, R2 are connected in series. Connect both in series. 2 are in series.
12 ohms.
And with this, 1 is in parallel. Is it right?
Yes, sir.
So here 6, here 6, here 6. So these two are in
Equal.
these two are in series. So you will get 12 and here it is 6. So 1 by 12 plus 1 by 6. How much?
So
1 plus 2 by 12.
1 plus 2 by 12. That equal to 3 by 12.
3 by
If you reverse it, 12 by
4
3.
ohms.
4 ohms. Is it right?
4 ohms, sir.
yes.
So this type of questions there are chances to ask in exam, Nana. Is it clear? Very easy, but understanding of question is little bit different. Difficult, you know. So answer is 4 ohms you will get here. These two are in series and the another version is in parallel. Final answer is 3 by 12 that equal to 12 by 3 and it gives 4 ohms. Yeah, last question and after this I will stop the class. What is the highest and the lowest total resistance by combination of the 4 coils of resistors 4 ohm, 8 ohm and 12 ohm and 24 ohm? What are the two possible ways to get highest? One is
Highest is 48 ohms.
48. In what type of combination?
I think
Series
first one can
combination.
get, sir. So first one can get in equivalent resistance, sir.
Yeah, both are equivalent only. But which type of combination here? Series or
Series
parallel?
combination.
Yeah, excellent. Here, series combination gives highest. 4 plus 8 plus 12 plus 24 is equal to 48. Very good. First one is 48 ohms. Done. Highest. Lowest. What is the combination to get the lowest resistance? Parallel.
Okay.
If you connect all in parallel,
So 2 ohms.
2 ohms you are getting a.
Connected all in parallel.
Yeah, that's it. 1 by 4 plus 1 by 8 plus 1 by 12 plus 1 by 24. What is the LCM?
4 is the LCM, sir.
24. 4 6 times, 8 3 times, 12 2 times, 24 1 time. How much it is? 9, 10, 12. So 12 by 24. If you reverse it, this is 1 by Req.
2, sir.
So
Sir.
Req is equal to 24 by 12. That equal to 2 ohms. Is it right?
Sir.
Yes, sir.
Req is equal to. Clear, Nana. Very easy. Don't get
Yes.
confused. Highest and lowest. Highest means series combination. Least means parallel combination.
Parallel.
Is it
Yes.
clear? 48 ohms and 2 ohms. Very easy question. There are chances of asking this question in 2 marks, Nana. Section B. Okay. So 48 ohms and parallel is 2 ohms. Is it clear? If you want to do, you can do here. How many 176 ohms resistor are required to carry 5 amps on 220 volts line? See, we know that number of resistors we have to find. R1, R2, R3 and so on. N value, N number of resistors. Is it right? So each
Yes.
resistor value is how much?
176 ohms.
Okay. R1 is equal to 176, R2 is equal to 176 and so on. And current is given. Current is how much? 5 amps.
5 amps.
Voltage is given. Voltage is how much? 220 volts.
220 volts.
We know that V is equal to IR. R is equal to V by I. Okay. So here, this is R equivalent. We don't have the R equivalent value. Okay. See, V is how much? 220. 220 by 5. How much it is?
44.
44, sir.
44 ohms. So R equivalent is how much?
44.
Each resistor is how much?
176 ohms.
So divide with this. You will get number of resistors. R equivalent is equal to 1 by how that is in parallel. 1 by R equivalent is equal to 1 by
Sir,
R1.
Sir, 4 resistors.
4 resistors are?
Yes, sir.
Yes, sir.
Yeah, that's it. No. Answer is 4. Okay. Now look at here. Step by step how to write in the exam. Number of resistors is N. V is equal to IR. These are the formulas. So to find the number of resistors, R equivalent is equal to R by N. So N is equal to how much? From this we can say that N is equal to R by R equivalent. Is it right?
Yes, sir.
So R equivalent is 44. R is 176.
176.
So that is 4. Number of resistors is 4. But however, just note down the step by step here. Okay, 4 resistors of 176 ohms are required to draw the given amount of current. Okay, thank you, Nana. Thank you so much for your patience. And I hope you understood this class. And in the next session, we'll discuss a few more problems based on this chapter. So that